Section 5.2, the addition rule and complements. Lesson objectives: use the addition rule for disjoint events, use the general addition rule, compute the probability of an event using the complement rule. So in this video we are going to compute probabilities involving compound events. Lesson objective number 1. Two events are disjoint if they have no outcomes in common. Another name for disjoint events is mutually exclusive events. These two pictures here are known as Venn diagrams. This is to illustrate the probability of event A happening. This is the probability of event B, and this is the sample space, which of course the total area equals 1. This is an example of two events that are disjoint. This is an example of two events that are not disjoint. Suppose we randomly selected a chip from a bag, and with each chip in the bag is labeled 0 through 9. Let E represent the event choose a number less than or equal to 2, and let F represent the event choose a number greater than or equal to 8. So if we were to look at the Venn diagram for this example, this is our sample space denoted S. These are all the outcomes. This is the outcomes for event E, and this is the outcomes for event F. And as we can see, these are disjoint. So if we wanted to find the probability of event E or event F happening, we would first find the probability of E, which would be 1, 2, 3 out of 10, and event F happening would be 2 out of 10, and we simply add these up and we get 5 out of 10, or 1/2. Okay, let's look at an example. The experiment is a card is drawn from a standard deck of cards, and we have 5 events. Event 1 is getting an 8, event 2 is a king, 3 is a face card, 4 is an ace, and 5 is a heart. Are events E1 and E2 mutually exclusive? Yes, because you cannot have a card that's an 8 and a king at the same time. Events 2 and 3 is no, they can happen at the same time. You can have a king and at the same time a face card. Recall, a face card is a jack, queen, or a king. C is yes, they are mutually exclusive or they are disjoint because they cannot happen at the same time. D is no, you can get the ace of hearts, which is both events happening at the same time. Last one, E, is no, you can get the 8 of hearts also. In this example, the experiment, 2 dice are rolled. We define the events E1 getting a sum equal to 10, E2 is getting a double, E3 is getting a sum less than 4, and E4 getting a sum less than 7. Events E1 and E2 mutually exclusive or disjoint? No. You can get 2 5s, which is event 2, that would be a double, and the sum of those equal 10. B is no also. You can get a 1 and a 1. That's a double, and that sum is less than 2. Event 3 and 4 are not mutually exclusive because they can happen at the same time. You can get a 1 and a 2. And then D is yes, they are mutually exclusive because you cannot get a sum equal to 10 and at the same time be less than a sum of 7. This is the addition rule for disjoint events. Probability of E or F happening is equal to the probability of E plus the probability of F. Now this can be extended to more than 2 disjoint events. So if we have 3 events and they're all disjoint, the probability of E or F or G would simply be the probability of E plus the probability of F plus the probability of G. And of course this can continue depending upon your number of disjoint events. Let's look at an example. The probability model to the right shows the distribution number of rooms and the housing units in the United States. A. Verify that this is a probability model. Okay, we have to make sure that each probability is between 0 and 1, which works, and then we need to check to see if the sum of these equal 1, and they do. So we verify that this is a probability model. B, what's the probability that a randomly selected house has 2 or 3 rooms? Well, these events are mutually exclusive. They are disjoint, so we simply add the probability of 2 plus the probability of 3, and we get the probability of 0.125. C, what's the probability that a randomly selected housing unit has 1, 2, or 3 rooms? Again, these are all disjoint, so we simply add up their probabilities, and we see it's 0.135. Lesson objective number 2, use the general addition rule. So this rule is applied if the two events are not disjoint. If we want to find the probability of E or F happening, then we simply say it's the probability of E plus the probability of F minus the probability of both of them happening at the same time. If they are mutually exclusive, this part is equal to 0. Let's look at an example. Suppose a pair of dice are thrown. Let E equal the first die is a 2, and F, the sum of the dice, is less than or equal to 5. Find the probability of E or F using the general addition rule. Okay, to find the probability of event E or F using the formula, we're going to say that's equal to the probability of E plus the probability of F minus the probability of E and F happening at the same time. And we're going to let event E be the color blue. So each of these outcomes is event E, 6 out of 36. Event F we're going to denote by red, and each of these outcomes is an outcome for event F. The sum is less than or equal to 5. And these three events are both blue and red at the same time, so that's 3 out of 36. That's the probability of E and F happening at the same time. If we use our formula, we see we take the probability of E, which is 6 out of 36, add the probability of F, which is 10 out of 36, and we subtract the probability of E and F happening at the same time, and that's 3 out of 36, and we end up with a probability of 13 out of 36. Now there's another way that we could approach this problem, and that's simply by just counting each outcome in such a way where we don't count an outcome twice. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 out of 36. So the general rule for a compound event. When finding the probability event A occurs or event B occurs, find the total number of ways A can occur and the number of ways B can occur, but find the total in such a way where no outcome is counted more than once. Lesson objective number 3. The complement of an event. Let S denote the sample space of the probability experiment, and let E denote an event. The complement of the event E is all the outcomes in the sample space that are not outcomes in event E. Let's look at a picture. This is what the Venn diagram would look like. Here is the probability of event E. This would be the complement, everything that is not an E. This is our formula. Probability of the complement of E is equal to 1 minus the probability of E. According to the American Veterinary Medical Association, 31.6% of American households own a dog. What's the probability that a randomly selected household does not own a dog? So we're going to approach this by using the complement rule. Probability of do not own a dog is equal to 1 minus the probability of owning a dog. So that would be 1 minus 0.316, which is 0.684. The data at the right represents the travel time for residents in Hartford County, Connecticut. A, what's the probability that a randomly selected resident has a commute time of 90 minutes or more? So out of this we see it's 4,895 out of the total. B, compute the probability that a randomly selected resident will have a commute time of less than 90 minutes. Our first step is we have to find the sum total of all the frequencies, and then we divide it by our frequency, 90 or more minutes, and we see that's 0.012. So for B, if we want to find the probability of less than 90 minutes, we can simply use the complement rule, and we take 1 minus our probability here, which is 0.988. Here's the ratings and suggested problems. Thanks for watching.